Our next presenter for the day is Ananya Mohanty, a master's student in Department of Civil Engineering under the supervision of Dominic Frigon, and she'll be presenting on mining phosphorus from wastewater using PNSBs.
In 2020, 6,000 million tons of wastewater was processed by the Canadian municipality. Such huge volumes of wastewater are a liability to the society. They pollute the lakes, rivers, and water bodies, causing massive pollution. But you may think that the wastewater that is generated by the municipality is treated in the wastewater. You're right, they are. But they produced even more massive volumes of sewage sludge that are either incinerated or disposed of in landfills. This sewage sludge contains important nutrients and minerals such as phosphorus and bacteria. Phosphorus is an essential commodity in agricultural industry. It contributes to 30% of the fertilizers that is applied on the agricultural field. If we were to take 10 tons of sewage sludge containing just 1% of phosphorus, it can provide us up to 100 kilograms of phosphorus ready to be applied on an agricultural field. Now, currently this phosphorus for fertilizer is obtained from mining phosphate rocks. These phosphate rocks are a non-renewable source of energy. They require money, energy, and effort to provide the equivalent amount of phosphorus. So instead of mining phosphate rocks, why don't we mine wastewater instead? And just how we require tools to mine the phosphate rocks, we mine the wastewater by using bacteria. But not just any bacteria. In my research, I use the purple non-sulfur bacteria, or the PNSBs, that has the capacity to store phosphorus within their body and thus help in accumulating the phosphorus. However, they are competing with the other bacteria that are present in the wastewater, thus for their survival. Thus, to select for this purple non-sulfur bacteria, I use infrared radiation. I apply this infrared radiation on my reactors containing wastewater and thus enrich the reactors with purple bacteria that can potentially sequester the phosphorus. Now, I'll let you in on a secret. You can select for very specific species of purple non-sulfur bacteria by changing the duration of time that this bacteria spend inside the reactor. To do this, I retain the bacteria in the reactor and take out a part of the water. This process is called decoupling. Or I remove equal parts of bacteria and the water in a process called coupling. By inducing these reactor conditions, I was able to enrich for two different groups of purple non-sulfur bacteria, which were distinctly different from each other, yet very specific. By doing this, I paved the way and go one step closer to creating a mineable wastewater treatment system where sludge is an asset and not a liability. Thank you.